Today. All right, first off, I want to send a shout out to our sponsors for providing us this awesome, free, and delicious lunch. All right. Yep. Whoop, whoop. Also, before we get started, I would like to know if there's any announcements that need to be made by anyone out here. Anna, all right, cool beans. Welcome to the stage.
Hey, I'm Anna Sherman. I run Codex X, which is the women's tech group, and we're having an event on August 22nd here, I think at 6 o'clock. We're going to be doing intro to adding authentication and users to a Rails app. So that's open to everyone. It's just a place for women to come feel safe. So if you want to come and learn too, you're welcome. Yeah, that's it.
Thank you. All right, does anyone else have any announcements that they would like to make today? All right, if not, we're going to go ahead and get started with a good friend of mine, Craig Lyons. Welcome to the stage, my friend. I don't know. He will explain what he will be talking about today. So, okay, I know what you mean. I was like, I can't explain this talking if I don't know. All right, so unfortunately, we had a last-minute change. Our speaker did not show up, so today we will not be giving that talk about, intro to video games or whatnot. So instead, we have two awesome people who are going to step up and do a quick lightning talk for us. And the first speaker is Craig Lyons. Huh?
Hi, this is a classic bait and switch. You came for video games. I'm not going to talk about that. I don't know anything about building a video game server. I'm sorry, but hopefully you're software developers. So I'm going to talk about a blog post that I put up recently, and just kind of go through it quickly. It's about software development workflow. So I'm VP of engineering for a company called Zillion. We're an insurtech startup, and we're relatively new. And I had the joy of getting to do everything greenfield, and make all these decisions early on and figure out what to work on and how to do it. I was previously with Carbon 5, and I had some really good experience there going from project to project to project. And I kept noticing there were things that I wanted in all my projects. And over time, over the course of this project, we would keep adding things that make our development lives easier and nicer and faster. And by the end of it, it was great. And then you'd move on to the next project and you'd start from scratch. And again, like over the course of months, it improves as you go. So this time with this project, what I decided to do was front load all these things that I really like. And by front load, I mean build those things early on, right out of the gate. So we had a lot of decision making to do early on, where we would have to, it's business requirements, technical decisions, things like that. So there's a lot of chatting, which leaves a lot of open time for development work. So rather than building something that might have to change or might go away, what I did is I settled on a basic tech stack and started building those workflow optimizations early on. So that way when it was time to actually get started writing code, all those things were already in place. So how many people have used a linter before? How many people like linters? How many people hate linters? And the same thing goes for formatters and things like that. There are other things like we try to reduce our build times if we're using continuous integration. We do all kinds of stuff like this, namespacing, figure out directory structure and things like that. These things come and go, and some of these are opinions, some of them are just straight up good ideas. So, why would we want to do this? Your productivity goes up because you bring these things in early in the life cycle of a project, so then they can impact your development time from the ground, right? From the ground up. So, the sooner it's in your workflow, the more time it can save you in the course of the project. Development becomes more fun because you're not worried about stuff. You don't have to go and set things up. You don't have to keep doing the same thing over and over and addressing problems and like, oh, I'll fix that later. All that stuff is out of the way. You can focus on your domain and your actual fun, hard problems. Onboarding becomes a lot easier. You get a new developer, and all this stuff is already figured out. So as long as they trust you and you haven't made terrible decisions, it's a lot easier to bring new developers on board. It's also more portable. So if you need to switch machines and you've got this workflow in place, ideally you should be able to just kind of bounce around, which is very similar to the onboarding. And there's like this compounding improvement, because if you start at a good place with your workflow, then it's going to keep improving as the project goes on. And then you take those things and you bring them to the next project, and it keeps getting better and better instead of getting good and then restarting and getting good and then restarting. So what are some of those things? This is where opinions come in, but these are things that I've found in real world projects time and time again. Who here uses Docker? Cool. So Docker is, everybody talks about Docker for deployment. I really like Docker for development. It's an abstraction that stitches together your services, and it can be so beneficial for deployment because you don't have any dependencies when you start a project. You just spin up your Docker container, and it's got your language, it's got all the tooling. You don't have to worry about the versions of things, whether it's Node or Elixir or whatever you're working on. It's all just right. And the same thing goes for a database, for example. You can have a Postgres container, and if you're using Docker Compose, you spin them up together, everybody has the same version of everything, and they're just up and running super fast. You get a side benefit of more likely mirroring your production environment. So if you're on a Mac, but you're deploying to Linux, you don't have that problem because your Docker container is Linux, just like your production environment. So whether or not you're going to use it for deployment, you should absolutely use it for development. I think it saves a lot of time. I recently started writing bin scripts for all my projects. And again, it doesn't really matter what you write them in. It could be Bash. You could use Yarn. The point is, it's really nice to have things that are named consistently from project to project. So for example, if you just run start, bin start, it's responsible for spinning up all your dependencies for your application in your development environment. So regardless of the tech stack, I don't need to know how to start the app. I just go bin start, everything comes up at once. And you know, it's easy to get carried away with these. I think I have like 25 of them on my current project. But same thing with running your tests, just run bin test. Then you don't have to remember as you bounce from project to project what you're supposed to be running. And another one that's really nice is Bootstrap. You run bin Bootstrap on a brand new project, and it installs everything that you need, and you're up and running. So a brand new developer can get started in 5 minutes. I recommend setting up continuous integration and deployment early on. These things change the way you work. And if you're not familiar, you should totally look into CI. But it's a workflow where you can push code, and you get instant feedback, and you also deploy the same way. So you don't waste time with the deployment process. Again, you get that out of the way early on, and you get used to it early on. I recommend creating all of your deployment environments right from the beginning, especially if you have any manual steps in your deployment process. Because you do all this stuff, you spin up your staging environment, and then months later, it's like, okay, it's time to set up production. What did I do in staging? And you have to go and remember that. If you set those things up out of the gate with your continuous deployment, 3 months down the road, you're going to be thanking yourself for doing it. I really like commit templates. Git has the ability to provide a commit template per project. So you can set up the things. When you go to make a commit, it'll fill in your message with these placeholders. And the developer is prompted to fill in those things with the things that you care about. So for me, I have a summary of what the commit does. I have a detail list, which is broken out in more detail. And then I have a reference to my tracker, story, whatever it is, where the details of the problem that it solves are stored. So that way everybody's on the same page. I do the same thing with pull request templates. GitHub provides these if you use GitHub. And what's really cool is your commit will fill in your pull request template. So you say, create pull request, and it's filled in with the details of your commit. And then the other thing I do with the PR template is I add a checklist for either the developer or the reviewer to say, okay, did I do this? Did I do this? There are no to-dos. Code coverage is good. So whoever's reviewing the PR is forced to go down this list and check everything off. And if it's part of the template, you kind of can't escape it. So it really enforces good practice. And use formatters and linters. So yeah, this is one of those super opinionated things. But in my experience, if you bring them on early in a project, people get used to them, and you reduce the churn. So people aren't, you put up a pull request, you're not seeing white space changes. You're not seeing editor mismatches. You're just seeing dense code changes, and that's it. So this can be bumpy if you bring it into a project halfway through, because people aren't used to having to deal with this. Like, I don't want to use this formatter. I like my code to look this way. But if it's that way from the beginning, everybody just kind of rolls with it, and things become a lot easier. So what's the downside? Yeah, it's gonna cost you some velocity early in the project. It's gonna take some time to set this stuff up. But like I said at the beginning, most projects kick off with some uncertainty. So while other people are figuring out other stuff, you can be optimizing your workflow so that you hit the ground running, and you'll have massive velocity benefits that easily make up for it at the end. That's it. Thank you.
Thank you so much. All right. So our next person to the stage is a good friend of mine, Aram Perez. Welcome to the stage.
Testing 1, 2, 3. So for those of you that don't know me, my name's Aram Perez. I started a company called the STEAM Train, where STEAM is science, technology, engineering, art, and math. And I'm bringing this $49.99 robot kit to the market. My dream is any kid that wants a robot should be able to get one, no matter their socioeconomic background. Some of you are familiar with Arduinos. This is based, well, the board is Arduino compatible. Me and a local really good hardware engineer designed this, but it has an ARM processor. Some of you may know what's called a Maple Mini. So we took a Maple Mini and then we added 2 motor controllers, a Bluetooth module, RGB LED, and a little speaker. And yeah, I gave a little lightning talk a while back. So once you build it, and it comes together with just 10 screws, and I provide the screwdriver. I'm a big believer in what's called the KISS principle, keep it simple, stupid. So there's a free mobile app, and this lightning talk I gave was on using, I wrote this or developed this with the help of someone else using something called native script. I think for the next version, Google came out with something called Flutter. I'm going to give that a try. But, you know, this is a free mobile app. There's a, what looks like eyes is an ultrasonic sensor, so let's see, it should stop automatically. Ran into it, but, oh, my batteries are running low. And you can put it in what's called the cat mode. At a certain distance, they'll follow you, and if you get too close, they'll back away. But then in addition, what I'm going to try to show here, I don't know how many of you, if you have kids, you've probably learned about Scratch. It's some software developed at MIT that's drag and drop. They have what they call blocks. Actually, we can... Oh, hang on. Got to run Chrome for this. So Scratch, you have sprites and you have backgrounds, and I don't got any, actually, I think I was teaching a summer camp at Chat State last week, so I think so for kids, it's very easy to learn. Each sprite you can control. The interesting thing about Scratch is it's not only multitasking, because each sprite is executing its own code. Energy is supposed to show up. I'm not sure why it hasn't, but. And you can do some graphical stuff here. So the cat is a sprite that has what they call multiple costumes. So as you move around, you can And then you have a pen. I don't know how many of you remember something called Logo that MIT developed years ago, so that you can basically do the same. Instead of a turtle, they call it a pen. So you can change colors and draw points. Here is just generating some random. But so this is really great for teaching young kids. And this, you can see it's a very simple program. So the kids just have to drag from here. There's the different categories of blocks. And, they sort of fit together like puzzle pieces. You can define your own blocks, or functions, what we, real programmers call. But for young kids in particular, or even high school, because sadly our schools have stopped teaching keyboarding, there's very little they have to type. And they don't have to worry about the syntax. No capitalization. You can actually, my style of naming things is the camel case, but Scratch actually allows you to put in spaces. Underneath, they hide all that. Now, not to be outdone, a while back, let me see here. Google came out with what they call Blockly. So if you see, it looks very similar, except that this is all JavaScript in the background. All this is free, and Scratch 3.0, so what I was showing you over here, the programs is called Scratch 2.0. That was based on Flash, and you can actually download a version that's standalone. Right here I'm connected, going to the MIT website. So, Google came out with this, I'm not sure exactly when, but the next version of Scratch, Scratch 3.0, or I guess they're calling it Scratch Blocks, is being built using this Blockly technology. And because I wanted, younger kids to use this, I created this using JavaScript and Blockly. This is sort of standard Blockly here. So need to get the MAC address here. Sorry. Hello, sir. Okay, sorry about that. Actually, here. Lockley has this option that you can highlight, although this will be quick. Questions? Yes. Yes. So I have, this is the complete kit. I also have one without a chassis that you can use if you go. I don't know how many of you guys are familiar with Instructables. Yes. So this is a kit that I sell without the chassis. This is just a piece of cardboard. Yesterday, I was out, it's called Booker Washington Elementary School. Yeah. And we built some robots out of cell phone case. Right? So I provide everything but the chassis. That's $45 for.
Describe the process of getting your circuit board printed.
Sure. My hardware engineer did all that. He used some open source software. I think it's called KiCad. I forget which exactly. He laid it out. We got the bill of materials, and then we had them built in China. I'm getting ready to order some more boards. We did have a problem. This little RGB LED here was put on backwards, so I had to pay someone to unsolder, flip it, solder. And then they didn't clean it correctly, so I had to buy some spray cleaner and clean all the mechanical switches. And right now the board is roughly $20 a board. But I'm hoping as quantities go up, I can drop, this will cost less, and eventually I actually want to sell the robot for less.
Any other questions?
As long as they know how to use a mouse, and they can drag things. I haven't tried Scratch on a tablet. You're supposed to be able to do it. I know with some Chromebooks, depending on who made the Chromebook. It's tricky to drag the blocks. But, as long as, they can drag things around on the screen, Now, to build it, I'd say around 10, you still have to know how to, screw, even though there's only screws, no nuts. But you still, need a little bit eye-hand coordination. But once it's built, then, anybody can program it. And then for advanced, if you're into embedded systems and you know C++, you can use Arduino IDE to program this.
All right. Any other questions? Well, could we give a round of applause to Greg and Aram for coming through for us to put together this talk? Yeah. All right. Well, with that being said, this concludes our luncheon. Thank you all so much for coming out. And